At some point, I opened parametric support. We got a grant in Berlin. What brought me there, like when I discovered I really love parametric design, like in Poland, that's why I actually started PhD to just give me time to learn.
Hello and welcome to the Architecture Beyond podcast. I'm your host, Brennan Gibbs, and today we have an awesome parametric design leader with us, Judie Curie, or Judyta Cichocka, so you can correct me. Welcome to the show.
Thank you, Brandon. It's my pleasure.
So you have a very interesting sort of segment of the parametric design world. Can you tell us sort of how you got into that and what it's all about with design optimization?
Yeah, design optimization, like it can be understood like in very different ways, like finding a proper shape or a proper procedure or proper material is also optimization. Yeah, we can optimize it on paper, like by hand or with just logic and just common sense. Yes, we don't need really tools. But like the domain I'm sort of working in is a domain where we have already these computational methods, and then we have optimization methods that are sort of borrowed from computer science and applied in architecture. And this domain had a new name, that is architectural design optimization, ADO. And all started, I think, on my third year of mass of architectural studies in my bachelor. So all started in the third year when I discovered parametric design, and I was just like, wow, this is it. You don't need to draw things over and over again. You can just program them, and then the logic is not lost. Yes, like once you figure out how to make efficient, I don't know, windows openings for some one design, you can apply it to some other design. It was this like game changer. I was like, okay, this is it. I want to do this. And once you have all these conditional tools, okay, and then you have, I don't know, millions, thousands of options that are available, like it's very hard to choose, yes, because you can design, like cup for coffee and just parameterize everything that you can have, like really a lot of variations, slightly, or like they can vary slightly or like a lot, yeah. So then optimization comes into play, yes, because we can sort of try to figure out like which design is like better for some under some chosen criteria, yes. So how to find the shape that like fits the most but like uses the less material possible and stuff like that. So I think this is how it started. And also I think like I was always like naturally attracted to efficient efficiency in life, basically. Like I try to optimize most of my how to say, yeah, like my flat is very small, but people say always that it's so optimized, in a way that, I don't know, everything is close, and we need to learn from nature how to actually do it, because nature is the best optimizer we know. But it's not like goal oriented as us architects, because we have something in mind. It's just like when you imagine a tree and the roots that they looking for, like which each day they growing a little bit, but they don't grow like randomly. As they grow into like they improve their situation, basically, yes, with each step. And this is what we try to learn from nature. And most of these methods we use, actually, it's like ant colony optimization, like particles from optimization, that is my domain, and that we actually adapted from fish and birds.
So your way into sort of parametric design is through architectural engineering, and that's where you found out design optimization. Is that a clear assessment, sort of? You were architect first?
I think just parametric design enabled us, yes, to apply optimization, like this modern optimization, like the computational optimization. And what got me also into that is Christopher Alexander. It's actually American architect, mathematician. I don't know. He was the first, like he was studying both mathematics and architecture, and he wrote this book, like Pattern of Language, a pattern language, that was about like a book,
okay, yeah.
in 77. But the book is written in a very particular way, that it's like, okay, you want to design a roof, open this page, and once you design the roof, you want to like put a window, like turn to this page to see like how to design a window. And actually this was super funny, because it was origin of object oriented programming, this book. And then he had another book like The Nature of Order. I think like I all these things I discovered at the same time, like at the just beginning of my studies, and I was like, wow. And he was like the first one also, um, maybe maybe not like totally the first one, but trying to like making logic of design like with graphs. That is very useful now.
Yeah, I've heard of pattern language. I looked into a lot of the Auburn studio, Rural Studio at University or Auburn University. They sort of follow sort of pattern language, but I know a lot of MIT was also influenced sort of how sort of the code behind architecture. We'll get into sort of what you're working on now in terms of founding the Fab
Hmm.
Lab Poland, which is also awesome, awesome design creation. But you're, I guess, so it's like you found a lot more before sort of really engaging more engineering at MIT, which I know it's known for it's known for engineering. It's not as much known for architecture, but you sort of created, you know, a mix. Like, how did you sort of take your interest there, sort of into engineering?
Oh yeah, I just entered MIT, the master program, when I was like 28. So most of the people, like, they're done with the education, the higher education, at least in our part of the world. And I was the oldest one at that. So what brought me there, like when I discovered I really love parametric design, like in Poland there's no formal education I could take, and so that's why I actually started PhD to just give me time to learn like all these tools, and I was taking whatever grant I could just to sustain myself and have time to develop skills. So I always wanted to have like education from some university that actually specializes in the thing, in conventional design, and also like I think I was looking to like use all my, like every of us has like some kind of potential, no, like we are usually like discovered on the way on, or we know like there are some things we are naturally good at, and I think the aim of people should be like try to use what we have like to the best extent. So I was also very good in physics always, and I really like mechanics. And I think my goal was to like just be one one of my heroes, like Felix Candera or Fray Otto, who were on the border of structural design and architecture. So, and honestly, like the optimized structures, like they asking you just the structures, like the optimized structures are naturally beautiful, like because they there's no spare material, the so this is like one of the examples when optimization creates beauty actually. So I just wanted to learn how to design structural systems. I mean, at that point I was already like living in Siberia, in Russia. I spent like 2 years in New Zealand. I spent 2 years, almost 2 years in Berlin developing my startup, and I was like not really willing to go. I was like, okay, let's try MIT or nothing,
So that's really cool as well. You're very well traveled around the world. So
I mean, honestly, it was not my wish. It was just like a necessity.
uh, I think that's a common thing though with architecture or just innovation. Like typically, just the place that you start in. Oh, look, there might not be the opportunity, so you expand yourself. So even in terms of connecting with Think Parametric, that's even further away. So I think that's all super interesting, and I think again, I think you achieved a lot before even going to MIT, and the idea is that was just another step for innovation. Do you think that that program or you work there? How did you take forward some of the ideas?
I mean, okay, like to talk about MIT, like I think it's a totally like it do need a separate podcast to like, but MIT is really magical place, and I first of all like I was searching for some kind of quality whatever like science, let's say, like some kind of quality in the field I try to learn, and once I got to MIT, I understood like this is how it should look like. I mean, I mean everything, the engagement, the passion, the courses, the like all the community, all the environment. There's many lessons I took from MIT. What they really care about is that you are motivated and you have some kind of passion. It doesn't matter what kind of passion it is, but you need to have some kind of drive, and this is what they appreciate a lot. And I think also this what took me there, because I'm telling you that I had to, of course, pass the formal exams like any other applicants, and honestly, it was. I never thought I can go to MIT and I will not have, I mean, without money. So first I applied for the Fulbright scholarship. Only when I got it, I start thinking how to apply to this MIT, and I had like maybe 2 months to get ready for all the exams. So, and they are like, they train you, they're not very complicated, but you need to be very fast solving them. So, um, yeah, I think that, I mean, of course, in terms of optimization, like, like I never, at my university, at my department for sure, I couldn't take any optimization course. And you come there and you have all of a sudden, yes, the multidisciplinary design optimization. You have, um, optimization methods, like purely mathematical methods. Then you have topology optimization of structures. Then you have computational design and optimization, computational design of structures and optimization. Yes, you have and artificial intelligence course. That is another, like, so you have so many great courses you want to, like, you can take, and actually you should specialize only in. There was also like um geometry optimization, so
No,
so
it
yeah,
sounds like the whole environment is like there, and I feel that too because I visited, done some research, talk with some of the directors there at MIT. I think they're doing very interesting and valuable work. Um, I feel that it's maybe even I don't know how much that program was ever connected with the MIT Media Lab, but I feel that the Media Lab is I found that more architecturally. So it's like they go in another direction because some of them they work with like big companies or even like the Department of Defense. So it's like they're they're a little more toward product design, but I think the way you're doing is a little more like pure. It's like it's a little more pure with theory, like versus a product. Or was your work there toward was it more of a research or was it like um, can you describe that process? Because I see that in some of the programs for design that either they're for an object or they're for a system, but then there are theoretical programs.
so at the moment I applied to MIT, I already sort of accomplished PhD in architecture. It's a longer story. I never wanted to have a PhD actually, but this was my way to. I applied for one grant that that my dean didn't let me to go and my master studies. Because I always wanted to live in like Russia and United States and then maybe come back. It just happened that at the end, like by traveling all the world, I just made some papers, and they let when I came back to Poland, it turned out you can defend PhD based on the papers. You don't need to like write the whole book, and you don't need to be there like all the time. So I had already PhD applying to MIT. So I applied actually to the Master of Engineering. This program is oriented for like professional oriented. So you have also Master of Science that is 2-year program, and then also it's intended that you continue to the PhD. So if you want to have a scientific degree, like you apply for Master of Science, and then it also works differently because you have like 20 hours per I mean, it's 50% you spend on your courses to learn yourself, and 20% of time you actually work for the lab, like you contribute with research and papers and whatever work is necessary. And the Master of Engineering was just shorter; it was just 1 year. Like at the time, like after finishing one, master and PhD, I just wanted, yeah, 1 year. I thought it was enough, but at the end, it was not enough. Like I stayed 1 semester more because it was so sad to leave MIT, and you always want to learn more.
I think that's very interesting, and it's like everyone has their sort of love hate story with school, but typically afterwards you always have these memories of or that research environment. It's even more than school when it's something that you love and you're interested in.
I mean,
Um,
I don't have these memories about my, university in Poland when I studied architecture. Like I don't have these memories. I
but it sounds like you've got a lot to sort of push your work afterwards. I guess we can move on to sort of life after your research. What was the transition? Um, I guess transitioning, sort of one of my points I have, transitioning from academic learning to professional practice does present, like, a different type of challenge where you start to deal with the real world. Maybe you're working with a company, maybe you're starting your own. But how did you navigate that transition from research to maybe practice?
I mean,
And
it's
what advice would you give to others embarking on that journey?
it's hard to say that I actually transitioned anywhere. I think I'm still suspended one like, in academia and one like trying something in practice. But I think this is I mean, I tried. Okay, I always work on the like. I really always work with the applied research. Like this is what Like I think theoretical research is not like my domain. I really like like when you um, come up with something innovative that is actually changing something in real world. Um, so I tried. Yes, I mean, I always work on the border, like with some companies, like collaborating with companies, industry companies, even in the early years of architecture with some um AJ system, for example. It was like innovative digital trusses, perfopo. Like I always had some kind of connection or free your mind. I was just modeling the models, and so at some point I opened with two other people like parametric support. It was a startup and we got a grant in Berlin. It was based on my research, like on the particle sum optimization. We developed a tool, and but honestly, like everyone, we made a few projects with famous even architectural offices. Everyone loved the results, but it was not fitting to the like business model. There's no one wanted to pay. Like there's no budget to pay for optimization. So I tried that. It didn't work out. And at the
But
moment, like I would.
it still sounds like it was a very bold venture for creating it. Like, I mean, even though some people like Starchitect, sometimes people say maybe they've maybe sold out or anything, but the idea is a lot of people you see, they have several ventures that they started, and it's maybe um discovering, what you're interested in. Like, I think that it was a net win, right? Or what would you say, that just starting and trying to see if the market, because that was probably the more hitting into practice, because I think what you said of 1 foot in academia, like, I think we never should lose research at all. I totally agree with that. I feel like, why would you pay for school and be part of such a great research environment and then give it up to work at a firm or something? I think it makes sense to continue it.
I mean, honestly, I would love to work in big R&D, with Arup or Buro Hapul or whatever. But I mean, I would love that, So it's like then you have your environment, but you don't need and you have like great applications, and they just come to you with a real problem and try to use something, state of the art beyond the state of the art to solve it, and we then implement it in construction. But to do that, I would need to leave Poland again, and that's what I mean. I sort of came back and decided that I want to make my, I don't know, just I want to stay. It's time to stay. Um, So I need to sort of create this R&D for myself. That's part of Foundation Poland, actually. Like that's the goal, that is gonna be a research institute, like trying to pursue like applied research, and actually it's legally founded as like both research and knowledge dissemination organization and also a company. So let's see how this is gonna work out.
But you did have some time at Burup Happel, but at the same time you wanted to do something more local in Poland. I guess
I mean, yes, but I was working with them when I was in US, when I was at MIT. Like, they saw my presentation of the like one of the final projects, and they really like my approach to like, this multi-objective and showing options, and then like trade-off, and then presenting like what is actually like difference in like because you can measure like some efficiency in, and actually I really enjoyed working with them in Boston, like engaged me into like grid shell projects, and I was like programming the geometry and optimizing. I really loved it.
well, I'm sure it was a very fresh perspective, though it's like it's a big company, so it's hard for a big company to change their ways. That's sort of why you would maybe, I guess, you can break into the story of how you came up with ideas for Fab Foundation, because it's like when you have more freedom in your research. I mean, what were the starting points, and how did you start that one? Because that's obviously that's like your baby.
Okay, so like I'm telling like okay, so after MIT, I decided like I was very lucky because when I left, I picked up my diploma. I mean, I didn't pick up diploma, but I sort of graduated, and I left Boston. 2 days after that, there was the first case of COVID, in Boston. So
Oh.
I just like finished, and the COVID started. So I came for the COVID wave in Poland. It was pretty hard for me because I haven't been living here for like a couple of years, so I didn't have like like that. You don't have network, you don't have the same couple of friends, friends that left, or they have three kids living somewhere else, or so it was very hard, and I so I cannot work really at university in my city because they don't offer like solely research positions. You need to teach, but at the same time they don't offer any courses I can teach. So I tried before like to apply with the idea of the new courses, but they never approved any of the applications. Then I was thinking, okay, so what to do to stay in Poland? Maybe I can get a grant for the company, and this is how I found Saule Technologies, because it's Olga Malinkiewicz, who is like also a very inspiring person. Like she also tried something totally new, like these solar cells with that are printed with ink. And I went to them. I was like, guys, maybe I can apply with you for some grants, and we can do something together. And they agreed. I thought it's like a good option. Like if I cannot work at uni, at least maybe I can work on something innovative in the company. But
That's cool. Yeah.
like how to say, it also didn't work out perfectly. Like because I don't have anyone that can supervise me. I'm also alone, like in a way that I don't have mentors. That so I'm working with them. They like give me some restrictions and everything, but at the same time I don't have really like meritocratic support. So I was like, okay, if I can do, I can do it on my own. I can
It
maybe open a new research institute. And the second point of Fab Academy, Fab Foundation Poland, is that I always also wanted to sort of like bring part of my experience from MIT and share it with people here. And I've discovered that Media Lab. Okay, so there is one famous course, How to Make Almost Anything, by Professor Neil Gershenfeld. And I also wanted to take this course when I was at MIT, but you don't have time for everything. Okay, you need to choose. But then I discovered that there is like a global version of How to Make Almost Anything. It's called Fab Academy, and it's organized by Fab Foundation Global. Okay, Fab Foundation Global is also run by Professor Neil Gersheven, and I mean he's like one of the main people there. And so I wanted for Foundation Poland to be like first of all to be a research institute that maybe we can just get grants and run like really research into digital fabrication and parametric design, like 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 just as a new entity. And secondly, to bring Fab Academy to Poland, to make people able to take this course here in Poland. So the course is, you have global lectures with the professor from Media Lab, and you make your homework locally in local Fab Lab. So to be able to run that, you need to have a Fab Lab that is accredited. So you have all the machines, and you need to have instructor that is already like that already passed the Fab Academy. So I went to Mexico a year ago. I graduated from the course. I'm now novice instructor. So this is the second goal of Fab Foundation. Like, and the third one is to create some kind of community, because at the end, like, MIT is a community. It's like sort of, it's funny, but once you join it, like, you never leave this family in a way, because you have forever the alumni account. Like, you can have MIT bank account. They send me like the MIT review every 2 months wherever I am. I just get it. So I think the community, creating community, is another point of Foundation Poland that I hope. I mean, this is my vision how it should work. That we're gonna sort of unit, like, build this community, and help Fab Labs actually to actually exist and sustain themselves. Because many Fab Labs, there was an initiative, for example, because there's always two problems: either there are no money to have a Fab Lab, or there's no people to run it. Like, that actually know and have passion about it. And so I would like to, like, create the Fab Lab in Wrocław, and like sort of as a model, also business model that maybe can be like like sort of repeated in other cities. So because yeah, some Fab Labs just died, like, and from one or the second reason. So this is the whole idea, okay, about the Fab Foundation Poland.
You're listening to Architecture Beyond.
In this episode of Architecture Beyond, we're hearing the journey of architectural researcher and engineering doctorate Judie Curie, and her exploits in the field of parametric design and digital fabrication. This episode is brought to you by the full-service architectural training platform Think Parametric, your source for future-proofing your expertise, with courses in the latest in architectural technology. To learn more, visit thinkparametric.com.
Well, that's an excellent way of how you're building it. You're not just, it's not just given to you. MIT, like you're saying, is that community, and ideas to start it somewhere else is definitely taking a bit of a mission.
I mean, yeah, it's a pretty hard mission so far. I don't know, like, let's see. I'm trying hard. Like, everything is like legally, like, established. I actually rented this space. We call it Fab Institute in Wrocław. Although we don't have, I have just small laser for now. But we need to get a first grant, okay, and maybe even two grants, and then with these grants I can buy equipment. So then we can become a real Fab Lab, and then we can run Fab Academy, and then maybe we can really conduct the research in digital fabrication, because there's many topics can be researched.
Yeah, I mean, I feel that's some of the similar idea, like with Think Parametric. I think if you also could talk about your connection to Think Parametric, because you did an excellent course on Karamba.
Yeah, you
to
watch
share,
it?
I did. I got into it a little bit, so I'm definitely, as sort of content creator with Think Parametric, I explore all the courses. Sorry. So the idea with the Think Parametric is that everyone should be able to learn these core skills in parametric design, some of the base skills in architecture,
Mm-hmm.
but then also it introduces what is sometimes considered more of the long view of architecture, like structural engineering. Like, what I would ask, sort of, how did you get involved with Think Parametric, and how did you, because I feel that's also part of the partnerships that you've created, and I feel that energy is something that is very exciting. Also, this would be shared with the Think Parametric community, so hopefully if there are people in Poland or interested in Poland, they could also contribute and help sort of that vision. Uh, can you talk about your background with Think Parametric and how
I
you brought
mean,
that idea?
s- um, so when I was actually working with Adrian Krejlik in Berlin on parametric support on this startup about optimization, uh, I mean, he came back from Mexico. He was living there 4 years, and I think this is how he got to know Think Parametric. And then I don't know. Somehow he matched us that they were looking somebody maybe to make a. I don't know if they're looking actually for, but yeah, like I knew Karamba. I really like Karamba. I like any structural design and analysis tools that are connected to Grasshopper. Not only, but so this is how it all started. It was the first course, like the basics of Karamba, and the second actually was. I think it's much better, honestly. Like is the second course. I think it's Karamba 102. I think it's the best course I
You
ever.
focus on Felix, so finally Felix
It was like
Candela.
form finding. Yeah, I
Okay.
mean, it was like two concrete shells, and then I really like it because it explains. I mean, I think it's the best course I ever done. So really, like I put my heart there, and also I was fresh after MIT, so some of the things, like I tried to put like some scientific or explanation in the beginning of the concepts and then like go to the practice. And I think also the choice of the case studies that are like developed in the course are really nice because all of them were built for real. Okay, so you can see like how you design what you had in mind and then like compare it or like contrast it with actually analysis of the real thing, how it works. So I think this is the best way to learn on the build, examples. So
How
yeah.
did you end up choosing Felix Candela? Because and sort of what is, I guess, could you give a background for him as well, because I feel that he might have had some similar struggles, because like he's like one of the only ones, like you see
I mean, so Felix Candela actually was a Spanish guy, but I think there was like some. He had to emigrate at some point to Mexico, and I mean, it was the era of 60s that where the concrete was very cheap and like sort of work was like the it was better to save on the material, and if even if you put more how to say human work, human first. um, so he was one guy that was thinking about fabrication, of the concrete shells. Because, for example, there is Heinz Isler that makes a very nice concrete shells, but they need a lot of scaffolding and everything. So Felix Canella figured out this way of using these mathematical shapes like hyperbolic paraboloids that can be constructed with straight lines. So you can have a double curvature, but using just straight lines as a scaffolding. And then, for example, this restaurant Los Manantales is he built just one scaffolding from the straight lines, and he was just repeating it all over again, and through most of his works, this Cuernavaca chapel and some other, like you can see this shape, hyperbolic paraboloid, but cut like different parts cut out of the same mathematical surface. That he was not thinking actually very much about the structural performance, just about constructibility. But it turned out that his intuition was also quite correct about the structural performance, because the restaurant still, like, okay, it has little cracks, but when you make the analysis almost purely in compression, and this is what you look for concrete structures. So yeah, this is Felix Candela.
it's and it's a more pure expression of both math and art, also science. That it's
So
I
it's
think it's
very optimized when you think about it,
it's very.
because he knew how to choose the shape that is material efficient, is constructible, and then yeah.
What do you see more architecture and engineering? Where do you see more of these ideas of optimization being applied?
Honestly, I don't know much because there's so many new tools. Like now, now we have just like a forest of tools, and sometimes we don't know what to use, and so of course it's, I don't know, like, of course artificial intelligence is something that it's coming, yes, to architecture as well. Like when my mentor professor Jacek Kościk used to tell me, like, oh, as an architect you always start with okay, I don't have a blank page, I think, with me. Like, you always start the design with a blank page, but it's not going to be a truth anymore, yes, because why we should start with a blank page when, like, if I need to design a school and so many schools were designed, why I need to start with the blank page? So um I think artificial intelligence for now, like, no, it's applied in the fields where we have digital representation, yes, like speech, maybe some images, yes, and I don't know, programming. It's very good in that. And in design, like, as long as we don't have a good, like, representation model, is not gonna be that applicable, but it's coming. So what I think, like, what we will need to focus, because it's going to be like taking care of the databases it uses, yes. So maybe architects are going to be now sort of like ethic judges, or like, that they need to focus on what to define as a good architecture or good design, I don't know, and what is fitted there, like,
It's parametric design is more the controlled side. Uh, Artificial intelligence, machine learning is something that is very connected what we do, but the new public model is often it's not really controlled by people. Whereas parametric design, we could use that in theory and research. I, I guess how could artificial intelligence help something like design optimization?
I mean, because look, like, again, like, how you can optimize, like, if you need to design a hospital, yes, you can try to optimize the form somehow, or try to, I don't know, draw the graph of the functions and then minimize the way escape route for the fire or something like that, or I don't know, optimize lighting. And then you need to define something that you optimize, and artificial intelligence is going to be more useful when you approach optimization from the other side, like this computational morphogenesis. So basically you don't know where you go, but you just improve, sort of, um so I think it's gonna be useful, yes. And why, like, if it's gonna be just having like good data, like, I don't see a point, like, it's gonna replace some of the things we do now as humans, no, like, for sure. um yeah, but there's nothing scary, no, we just need to sort of be open, and people that are like think, oh, I've graduated, and I'm gonna never learn again, it's done, my exams are done. No, like, we need to learn all our lives. So,
Um, well, I guess what would
and
you
it's
say?
mhm.
No, no. Even in terms of that, what would you say to a young designer who is interested in design optimization? What would their path be? Maybe if they're in their first college, where would they go in terms of
I mean,
with that
like,
skill
this is
set?
a this is very individual topic, because I sort of like personally advise already some people, like, like, based on the interest, where it would be nice place to go first, or like, because in the field, of course, there are like um universities are specializing in something. So if you're interested, yes, in timber, maybe you should go to Sweden, no? Or maybe, like, if you want to work with concrete, you go, and robots, you go to ETH, and so on. So it's
What's
very
ETH?
like, it's ETH in Zurich.
Zurich.
So
Okay, yeah, I think I heard of that one.
yeah, they
Uh,
got, like, they're now leader, I think, leaders in like robotically built architecture. And Philip Bloch, professor, who was actually like he who wrote like one of the most distinctive PhDs at MIT, now he's like the I think professor and director of the department there. uh so it very depends, but what I would um my advice is just to, like, learn methods and not tools. because like the languages and tools are changing so fast, and there's MIT is even inventing their own languages like Julia or something. So if you understand like the concept, then you can implement it in any language or any tool. So I think this is what I maybe I knew that somehow, but this is something what struck me at MIT really, that really the tools, the implementation doesn't matter, like it matters what is the foundation, and always the foundation you need to learn manually. Okay, so even if it's very complicated iterative like formula or something, you just need to write by hand the first formulation, the problem, first iteration, and then okay, for more iterations you let computer do it, but you need to know how this is done, and this is something really what is missing here, because I have impression, at least in academia, in my in Poland, let's say, like the tools, like people are asking, oh, did you use this, or is it in the beam? And this is, sometimes the tool is overpassing the content. This is very wrong.
The method is where people need to elevate above just the tool,
Exactly.
because
This is yeah, this is what, how to say, this is our skill to understand the method, because the machine is going to be always better in executing.
and it's the same thing as so myself. I'm also, after having such like a experience with a fab lab, for myself from Architecture Association, dealing with a lot of those sort of, like, I was part of the design research lab. So we have, like, after experience like that, you can pick up a 3D printer, you can pick up a laser cutter, you can, get the latest version of Rhino or something. But the idea is you're working with them is the symphony that brings everything together. So I think
Exactly.
that's excellent, excellent advising. I feel also that one of the key things in sort of your story is also finding different collaboration, because obviously, you know, to start something, you have to start somewhere, and finding partners. What would you say to maybe more developed researchers who are looking to collaborate? What would you advise for collaboration, or even maybe to avoid
I
collaboration mistakes?
I think I accidentally, like, like made all these collaborations. I mean, sort of accidentally, because I was looking for a place where to go study optimization, but I was from architectural department, so this is how I ended up in New Zealand. For example, I talked to the computer science department. I was like, guys, I'm sorry, I'm from architecture, but I really would like to study, like I really would like to learn optimization. And this is actually, they taught me about particle swarm optimization, that is uh, like the first optimizer, and like sort of my field now. But it was really cool, because like they had totally different mindset, and when I showed them actually these methods, they just see as like numerical results, and then I showed them that geometry can be optimized with these methods, and they see like the whole geometry changing. They were like so impressed, like that you actually see like this optimization. So I think all this happened sort of accidentally, because then I went to TU Berlin when we got the grant for the startup. It was a mathematical department, so it was more about geometry optimization. Um, and yeah, it's like that. But I think what is also MIT rule, sort of, they try to keep diversity and inclusion and equity, because this is what sparks innovation. So I think it's very nice so when we try to find collaborators, we should find, of course, people that I don't know, like I think it's very
Is to
interesting to making this
think out of the
interdisciplinary.
box. Would you say it's like thinking out of the box versus, if like an architect goes to another architect, it's not diversity.
Yes,
You
exactly,
talk.
exactly.
Uh, that's cool.
So I think this is what they learned, and this is how they compose. Also, like in my program, it was just 10 people, but everyone was from like different background. Like we are all different. So they put you together like all this, and try, like, and see what happens. and then they also force you to collaborate, because no one is good enough to deal with everything, so we need to collaborate, and then we help each other. So I don't know what is the the recipe for the best collaborations, but
You have to get started, right? And I think those are also just still some great points, because it's just pulling someone outside of their maybe maybe their particular class or their company to start something new, and that's where you can find new innovation, new opportunities. That's what I'm hearing, and I think I totally agree with that. Looking toward the future, what do you see trends emerging between architecture and design optimization? Uh, how do you think you know people who are in that area of design, or even just maybe in the traditional architecture, where can they look for the future um, with that?
I think, yeah, this is what I already like sort of sketched out. Like, I think the artificial intelligence is gonna play an important role, and this is another thing I'm working with Mateusz Wieżycki. Is because when we think about architecture and artificial intelligence helping out, I mean, because this is how I see the optimization future. Because mathematical optimization is not that good. Um, when it comes to architecture, because many features are not numerical. Yes, you cannot describe, oh, is it like I like this proportion, is it proportional, like, so there are a lot of features that we as a humans pay attention to, and give a value as a design, like beauty is another topic that we don't like to discuss. Yeah, it's beautiful or not, and that cannot be expressed for the mathematical tools we use with optimization. But I think artificial intelligence could have ways, to, like, you can incorporate these features into at least search, or get some suggestions. Or so I think this is gonna be more like it's funny, organic way of optimizing with AI. But then we need to figure out the new representation models. Like, also took a course of artificial intelligence at my last semester, and there was a statement that, like, knowledge representation model is the most important when it comes to artificial intelligence. So basically, like switching from raster image to vector, like, for computer scientists was like, wow, like this vector
Mm.
carries so much different type of data, like it's so much more information, it's so much more accurate. Maybe we should use actually vector, instead of just raster. When, for our, like, graphic designers, it's obvious, no, that like the vector is more correct. So we need to find this kind of new knowledge representation models for the reality. And this one of the projects I'm also working with Mateusz Zwierzycki's Phenomy. It's maybe soon is gonna be released. It's actually his idea of creating a new knowledge representation models for processes of production. And uh, and I think it's really genius idea. So it would help basically to create, in the same language, describe processes of production, of any production, and then in this way, like, save us, like, even, like, um, because you can describe it like step by step, like this, like how to make, I don't know, an egg, yes. But this model would allow everyone to use the same um, language that could be understood by computers. So the first of all, like, save, how to say, like, contribute to heritage, yes, because maybe some local processes can be saved, and then like, it's gonna be digital version of the process, of the know-how. uh I mean, so I
So
think
no,
it
it's
was
it's like working with models. I think is that's a new way of doing things. Something that would help control the innovation, or steer the innovation. Not really can just control it, but the idea is if innovation is sparking out of control, the idea is that, like you said, the knowledge, like a knowledge model over that. Would that capture that idea?
I mean, what I'm saying is that, like, if you want to use, for example, if you want to use AI to help you with some, let's say, I don't know, cooking, yes, you need to have the way that, like you create your database with the data form that is actually representative for, what you've done,
Mm,
and also it can be read by computer. So I think this is going to be the challenge to, express more things in digital, create digital twins of reality of the process in design.
yeah. To have there would be a world of databases behind your systems.
Exactly. So like how to create these databases, yes, and then a lot of ethics, no.
Well, it's been so informative. I know it's gone over my head. At the same time, it's so much inspiration. You've given a lot of great links. Um, but where can people find the latest work by Judy Curie? And
Judycurie.com.
okay, awesome.
I mean, I try to like keep this website as like because sometimes, like when you have a CV, you need to like select some positions, but there I keep stuff everything. So, and also the latest projects. Um, but also, I mean, on the fabfoundation.pl. So
Okay.
I mean, I'm all like I'm now. I hopefully soon I'm gonna be fully working only on the foundation. So then like and LinkedIn, of course, like like I used to use Facebook, but now LinkedIn is everything when it comes to professional life, let's say.
Well, that's brilliant. It's been a great show, and obviously, more people will join the conversation by following those links. Thanks so much for joining us on the show.
Thank
Uh,
you, Brandon, for inviting, Klein, and your patience, because yeah, it took us a little while now to
it
organize
took a
this
while,
meeting.
but it was so meaningful, and it was so rewarding, and I'm sure the audience enjoyed that as well. And so, thank you so much.
Thank you. So have a good day.
And thank you to the audience of Architects Beyond for joining us. Again, check the description of the video or the podcast that you're listening to hear more and learn more about the awesome work with design optimization and about Fab Foundation from Judie Curie. So,
This episode of Architecture Beyond, featuring the parametric design accomplishments and insights pioneered by Judie Curie, was sponsored by the architectural course platform Think Parametric, where you can learn the fundamentals of architectural engineering with software like Grasshopper and Karamba in the links below. You can also stay tuned to the latest Think Parametric content to advance your career at the Think Parametric blog, and in the innovative newsletter Discover Parametric Weekly.
in the next episode of Architecture Beyond, we catch a glimpse of how to preserve the life cycle of buildings with building management with the founder of the SiteWise app, Jeff Thornhill. Be sure to check it out. This has been Brandon and the Architecture Beyond crew. Catch you in the next episode.